Hi everyone, this is the video lesson for Pascal's triangle and binomial theorem, day 2, part 1. If you haven't watched day 1, part 1 or day 1, part 2 yet, please go back and watch them before continuing with this video. In the last part of part 2, we finished with example 1a and 1c. We're going to continue with 1b. 3x plus 2y to the power of 5. So again, the first step is to recognize that the exponent is going to be 5, which means you're going to copy this 6 times. Now once you copy this 6 times, again you go back to the first term, the exponent is 5. So you're going to count down from 5, 4, 3, 2, 1, and if you're doing it right, you will always end up at 0. Then you do it the other way, 5, 4, 3, 2, 1, and again you stop at 0. Then you go back to the triangle, and again the exponent, it tells you the row number. So the fact that the exponent is going to be 5, you're focusing on row 5. And the coefficients are going to be 1, 5, 10, 10, 5, and 1. And the final step is you're adding, so you put a plus sign in between each term. Again, here comes the final answer. Let's make sure you are connected, and you can take the calculator if you like. You can do mental math, you decide. Now you got to be really comfortable with the exponent laws. So for example, 3 to the power of 5, that's going to be 243 times x to the power of 5. 3 to the power of 4, that's going to be 81. You multiply 81 by 5, that's going to be 405 times x to the 4 times y. Now, there's a 2 here that I forgot, so it's 405 times 2. It should be 810. Let's try this again. So 3 to the 4 times 5 times 2, so 810. Let's keep going. Plus, again, you take 3 to the power of 3, that's going to be 27. Multiply this by 10. 2 times 2 is 4. 4 times 270, that's going to be 1080 x cubed y squared. Plus 3 times 3 is going to give you 9. Multiply that by 10 times 8, because 2 to the 3 is 8. That's going to be 720 x squared y to the power of 3. 5 times 3, that's going to give you 15, times 16, because 2 to the power of 4 is going to be 16. That's going to be 240 x y to the 4. Plus 2 to the power of 5, that's going to be 32 y to the power of 5. So again, this is how you can expand using Pascal's triangle. Just to be clear, something I didn't mention in the first day, there is another method, right? The second method is called the Binomial Theorem, but because we are relating it to Pascal's triangle, I'm just going to focus on this one approach. Number 2, find the third term of x plus 3y to the power of 9. Now, there are a couple ways of doing this, and of course, the shortcut is something that will be presented to you in grade 12 data management. So at this point, what we can do is expand the first couple of terms, and then we can address how to get to the third term. Again, there is a shortcut. I'm not focusing on the shortcut. I'm just simply showing you how to find the third term if you're expanding this as follows. So again, you know by now there would have been 10 different terms since exponent is going to be 9. But since you want to find the third term, really, you're just going to copy this 3 times. So you have the first term, the second term, and the third term. Again, 9, you're going to count down to 8, then to 7, and ideally 6, 5, 4, 3, 2, 1, and you stop at 0. And if you go backwards, you end up getting 2, 1, and 0, just like that. And of course, a quick way to verify this is the exponents will always add up to 9. That's how you can tell you're doing it right. Again, the exponent is 9, so you're going to focus on row number 9. And notice we don't have it here, which is fine. Let's write this out. 1, 9, 36, 84. And again, you just need the first three numbers, 1, 9, and 36. So you go back and you write down 1, 9, and 36. And of course, since you're adding it, it's going to be a plus sign for all of these. And the question is really asking specifically for the third term. So they're not asking you to expand the whole thing. They're asking what is the third term. So if you, again, take the calculator, or you can do mental math, 36 times 9, because 3 times 3 is going to be 9. That's going to be 324 x to the 7 times y squared, just like that. Now, part B, find the last term of a minus 2b, the entire binomial to the power of 6. So again, if we were expanding this, you're going to copy this 7 times, and you can tell that the last term is going to be a times 2b, just like that. Again, if you're counting 6, 5, 4, 3, 2, 1 all the way to the last term, this would give you a 0. And if you go backwards, that would give you a 6. The fact that the exponent is going to be 6, you're thinking specifically row number 6. So if you go back and relate to this, the last number is going to be 1, which you could have done mentally as well. So in terms of the last term, this equals to 2 to the power of 6, which is 64, times b to the power of 6. Now again, you try this first, and after you press pause and finish, and you press play again, I'll be right here. Okay, so for 2c, they're asking you to find the coefficient of the middle term of a squared minus 2b, the entire binomial, to the power of 12. So by now, you should be able to see this. And what I mean is, you know there are 13 numbers, or 13 terms. So if you count this, there'll be 6 terms on the left, 6 terms on the right, and the middle term is going to be the 7th term. So what they're really asking is the 7th term, right? In the middle term, in this problem, is the 7th term. There's 6 on the left, 6 on the right, and the middle one is going to be the 7th. So you already know it's going to be a squared and 2b, just like that. And you also know those numbers must add up to 12, and if you're counting down, right, so if you're taking 12 minus 1, that's going to give you 11, and then you get 10, 9, 8, 7, 6, that's going to give you 6 right there, right? So again, you're just counting down, and you can confirm this because if you kept going, 5, 4, 3, 2, 1, 0 is the other 6 terms, and you know this is also going to be 6 because they add up to 12. So again, you go back to row number 12, and it's not here, but it is somewhere here that we did in the first page. And if you look at this, row number 12, right here, the middle term is going to be 924. 924. So you go back and you write down 924. And you also have to look at the signs. And again, it's a shortcut, I know, but if you count the signs, it's plus, minus, plus, minus. And since you're looking at the 7th term, you can even mentally count plus, minus, plus, minus, plus, minus, then plus again. So effectively, this would give you, and again, you can take the calculator, 924 multiplied by 64, since 2 to the power of 6 is going to be 64. That's going to be 59,000. Let's write this again. 59,136 times a to the power of 12 times b to the power of 6, just like that. Let's keep going. Here's another lesson for sure you're going to learn if you take grade 12 data management, and this is applying Pascal's triangle using pathways. And technically, you know, there's a checkerboard example if you really take data management, and this is a pathway example just want to share with you in this video. So how many paths going down and to the right are there from point A to point B? Use Pascal's triangle method and count and counting principle if feasible. So I'll show you 3 of these. The rest you can try, of course, and we'll go from there. So if you look at this carefully, there's really 2 ways you can move. Either you're going to move to the right or you're going to move down. Those are the only cases. You can't go up, you cannot go to the left. So the first thing is you can put a 1 going to the right and 1 going down. Notice we're putting the numbers on the vertices. You don't put them in the boxes. This is not a checkerboard example, it's a pathway example. And again, what about this space right here? Well, there are two ways to get there because you could have taken this first pathway or this second pathway, so there are two ways. And of course, the shortcut is you can look at Pascal's triangle using this diagonal line. So hope if you rotate this to the right by 45 degrees, or you rotate yourself 45 degrees to the left, you can recognize Pascal's triangle. So likewise, this will be 3, 3, you're just adding it. 1 plus 3 is going to give you 4, 3 plus 3 is going to give you 6, that's going to give you 4, and you just keep going. This is going to be 5, 10, 10, and 5, 15, 20, 15, 35, 35, and of course the total number of ways is going to be 70. Okay, so that's how you go through example A. Now if you look at B, it's really the same as A, C, same idea. Whereas D, E, F, G, and H, this is slightly different because they took part of the pathways out. So maybe I'll jump straight to H just to show you what that looks like. Again, very doable. You can only go to the right or you can go down. So start with the ones going to the right and going down. Now again, 1 plus 1 is 2. There are two ways to get there. And again, I hope you recognize Pascal's triangle. 2 plus 1 is going to give you 3. 2 plus 1 is going to give you 3 again. 3 plus 3 is going to give you 6. 3 plus 1 is going to be 4. 4 plus 6 is going to give you 10. Now, you got to jump and move on to this spot. So for example, 1 plus 3, that's going to give you 4. 1 plus 4, that's going to give you 5. To find this spot, you got to find 10 and 5, which will add up to 15. So again, you're really still applying the concepts from Pascal's triangle. Maybe I should take a step back. 10 just means these are both 10, and then this will give you 15. And again, 1 and 4 is going to give you 5, but let's slow it down. Let's write down 4 and 4 first before we reach to 5. Then 10 plus 4 is going to be 14. 14 plus 4 is going to be 18. 14 plus 10 is going to be 24. 24 plus 10 is going to be 34. 34 plus 15 is going to be 49. You go back to the top. 18 plus 5 is going to be 23. 24 plus 18, that's going to be 42. Plus 34, that's going to be 76. Plus 49 is going to be 125. You go back. 23 plus 42 is going to be 65. And if you keep going, that's going to be 141. This should be 266. So the total number of pathways would be 266 ways. So again, try the rest of this, B, C, D, E, F, and G. And of course, there's also some homework on the next page. And I am going to post one more video, day 2, part 2, to give you a little bit more. So until next time, all the best, and I hope this makes sense.